Welcome to my channel. Today we are going to solve previous year EAMCET questions from current electricity chapter. Okay, you can find first 5 questions in my previous year video. Now let us go to sixth question. What is sixth question? A copper wire of radius 0.1 millimeter and resistance 2 kilo ohm is connected across a power supply of 40 volts. The number of electrons transferred per second between the supply and the wire at one end is. Okay, so this is question. Now what did he give? He asked us to take a copper wire. You take this as a copper wire. Okay, you take this as a copper wire. Okay, this is a copper wire whose radius R is equal to 0.1 millimeter. That is equal to 0.1 into 10 power minus 3 meters. The resistance of this wire is given as R is equal to 2 kilo ohm. 2 kilo ohm. That is equal to 2 into 10 power 3 ohm. 2 kilo ohm. Now this wire, if I take this as the starting point and this as the ending point, AB is a wire. Now this wire is connected to a power supply, that is to a battery, which gives a potential of 40 volts. Okay, so potential V is equal to 40 volts. Now what you have to calculate? You have to calculate the number of electrons transfer per second. That is, you have to calculate N by T. Number of electrons transferred per second is how much? You have to calculate number of electrons transferred per second. Okay, now this wire is connected to battery. That is, this wire is connected to a circuit. Then what will happen? Current will flow in the circuit. Let I be the current flowing in the circuit. Now this 40 volts generated by the battery will be dropped across AB. Now according to Ohm's law, we know that the potential drop across any section of a wire or any part is given by V is equal to IR, where I is the current flowing in the circuit, R is the resistance of the wire in this case. Then what we can write? We can write the formula for I as I is equal to potential VAB, that is potential developed across AB, by resistance of the wire RAB. That is equal to VAB can be written as 40 by resistance of the wire is 2 into 10 cube ohm. So then what will you get? That is 20 into 10 power minus 3 amperes. That is 2 into 10 power minus 2 amperes. Okay, so this 2 into 10 power minus 2 ampere current is flowing in the circuit. Now what you have to calculate? You have to calculate number of electrons transferred per second. We know that the formula for current is I is equal to Q by T, which is nothing but rate of flow of charge. Q can be written as NE, that is number of electrons into charge of electron by time. From this I can write like this: N by T, which is nothing but number of electrons transferred per second, is equal to I by E. We already calculated the value of I as 2 into 10 power minus 2. 2 into 10 power minus 2 by E, which is nothing but the charge of electron. It can be written as 1.6 into 10 power minus 19. Okay, now if I solve this, what will I get? I'll get the value of number of electrons transferred per second as 1.25 into 10 power 17 electrons. 1.25 into 10 power 17 electrons. Okay, which is nothing but option B in our sum. Okay, now let us move to next sum. Our next sum is the wire of a potentiometer has a resistance of 4 ohm and length is 1 meter. It is connected to a cell of EMF 2 volts and the internal resistance is 1 ohm. The current flowing to the potentiometer wire is. Okay, now before solving this sum, you should know the difference between terminal potential V and EMF. Okay, if I consider a cell of EMF E and internal resistance R, now if I connect this cell in the circuit, then what will happen? and if this cell discharges, then what will happen? This cell will give a potential V in the circuit, which is related to EMF and internal resistance as V is equal to E minus IR. Okay, so this is the difference between terminal potential, and this is the relation between terminal potential and EMF. Remember that EMF will be different from terminal potential, and the formula that connects these two is V is equal to E minus IR when the cell is discharging. Okay, now let us come to our question. That is, now what did he do? He asked us to consider a wire. So this is a wire whose resistance is 4 ohm and its length is 1 meter. Now length doesn't matter in this sum. Now this is connected to a cell. This is a battery. This is connected to a cell. Okay, this is connected to a cell whose EMF is 2 volts and internal resistance small r is equal to 1 ohm. Okay, then now what you have to calculate? You have to calculate the current flowing in the circuit, I. So you have to calculate I, which is nothing but the current flowing in the circuit. Now, so now what you have to do? You have to, since this cell is connected in the circuit, now you have to calculate the terminal potential. So the formula for terminal potential will be V is equal to E minus IR. This can so now V is the potential, terminal potential, which is nothing but the potential generated by this cell. Now this potential will be dropped across this part. So this V can be written as IR. According to Ohm's law, V is nothing but the potential dropped across this part. That can be written as IR, where R is the resistance of this wire. So what can I write? IR is equal to E minus I small r. Now I'll take this to this side. Then what will I get? IR plus I capital R plus I small r is equal to capital E, EMF. So what are you supposed to calculate? You are supposed to calculate the current. So from this, if I take I as common, if I take I as common, then what will I get? I is equal to E by capital R plus small r. That is, now let me substitute. E is the terminal, E is the EMF, which is given as 2 volts, by capital R is the resistance of the wire, that is 4, plus small r is the internal resistance of the cell, which is 1. That is equal to 2 by 5, and if you solve this, we will get as 0.4 ampere. Okay, now let us move to our next sum. Our next sum is the external diameter of 5 meter long hollow tube is 0.1 meter. Okay, and the thickness of its wall is 0.005 meters. If rho is 1.7 into 10 power minus 8 ohm meter, then its resistance will be, means you have to calculate the resistance. Okay, now you consider this as a hollow tube whose length is 5 meter. Okay, whose length is 5 meter, and he gave the external diameter as 0.1 meter. That means this distance, which is nothing but the diameter of the tube, will be 0.1 meter. Okay, and the thickness of the valve is the thickness of its wall, that is this colored part. The thickness of this colored part will be, is given as 0.005 meters. Okay, then what did he give? He gave the value of specific resistance, which is nothing but resistivity, as rho is equal to 1.7 into 10 power minus 8 ohm meter. Now what are you supposed to calculate? You are supposed to calculate the resistance of this hollow tube. Okay, now see, what did he give? He gave the external diameter or outer diameter, that is diameter of this outer ring, as RO is equal to, see, he gave the diameter of this outer ring as 0.1 meter. Now the radius of this outer ring will be, if I take this as center, then this distance, which is nothing but the radius of the outer ring, will be RO will be equal to diameter of the outer ring by 2, that is 0.1 meter by 2, that is 0.05 meter. Okay, now what did he give? What did he give? He gave the thickness of this what you call colored part as 0.05 meters. Now what you have to calculate? You have to calculate the radius of the inner ring. Radius of the inner ring means, if I take this as center, this will be the radius of the inner ring. So the radius of the inner ring will be R inner is equal to radius of the outer ring minus thickness of the colored part. That is radius of the outer ring, that is this radius minus thickness of the colored part. Then what will I get? That is equal to 0.05 minus 0.005. Okay, that is 0.045 meters. Okay, so the radius of the outer ring is 0.05 meter and the radius of the inner ring is 0.045 meter. And now what are you supposed to calculate? You are supposed to calculate the radius of this wire, radius of this hollow tube. We know that the formula for radius of any wire is given by R is equal to rho L by A. Okay, where rho is the specific resistance, which is 1.7 into 10 power minus 8 in this sum. L is the length of the wire, which is 5 meters. A is the area of cross section. Now, what is this area of cross section? This area of cross section is nothing but the area of the colored part. That is nothing but area of the outer ring minus area of the inner ring. Okay, now we can write, we know the formula for area of ring as pi r square. Now this can be written as pi r naught square, that is radius of the outer ring, minus pi ri square, which is nothing but the radius of the inner ring. Now if I substitute ro and ri, what will I get? If I take pi as common and substitute ro and ri, what will I get? Pi into the value of ro is 0.05 whole square minus the value of ri is 0.045, that is 0.045 whole square. Okay, now this is a square minus b square. This can be written as a plus b into a minus b, that is pi into a plus b, that is 0.095 into a minus b, that is 0.005. Okay, now if I calculate this, then what will I get? I'll get the area of cross section, the value of area of cross section as 1.49 into 10 power minus 1 meter square. Okay, now so this is the area of cross section. Now you have to calculate the resistance and we'll use this formula. So what will you get? R is equal to rho, which is nothing but specific resistance. Its value is 1.7 into 10 power minus 8 into length of the hollow tube, which is 5, by area of cross section of the tube, which is nothing but area of the colored part, that is 1.49 into 10 power minus 1. Now if I solve this, I'll get the value of resistance as 5.7 into 10 power minus 5 ohm. Okay, this is our 8th sum. Now let us move to our next sum. Our next sum is, in given figure, an ammeter reads 5 amperes and voltmeter reads 40 volts. The actual value of the resistance is, okay, so this is a given figure where you have ammeter, where you have voltmeter and where you have resistance. This ammeter is reading a current of 5 ampere and this voltmeter is measuring a potential of 40 volts. Now you have to calculate the value of resistance of this resistor. Okay, now see what I'll do. I'll take the current coming here as I, which is nothing but the current read by the ammeter. Now this current will split into two parts, which is IR, which is nothing but the current flowing through the resistor, and IV, which is nothing but the current flowing through the voltmeter. Okay, now we can write I as I is equal to IR plus IV. Okay, now we can write IR as IR, which is nothing but the current flowing through the resistor, as IR is equal to I minus IV. Okay, now according to sum, I is given as I is equal to 5 amperes. Okay, then and voltage read by this voltmeter is given by V is equal to 40 volts. Now IR can be written as IR is equal to 5 minus IV. Okay, now we know that this voltmeter has high resistance. Since it has high resistance, so very less amount of current will flow through this voltmeter. That is, the value of IV will be far less than 1 because of its high resistance, because of the high resistance of the voltmeter. Then what will happen? So 5 minus a small value, that means it will give a value which is less than 5. That is, the value of IR will be less than 5 amperes. Okay, so means the current flowing through this resistor will be less than 5 amperes. Now what is 40 volts? This 40 volts is the voltage measured by the voltmeter, which is nothing but the potential drop across this resistor. So what can I write? The potential drop across this resistor, that is 40, can be written as IR, that is current flowing through the resistor, into value of the resistor IR according to Ohm's law. Okay, according to Ohm's law, we can write V is equal to IR, no? So if I apply that, what will I get? I'll get 40 is equal to IR into R. Now IR can be written as IR is equal to 40 by capital R. Okay, IR is equal to 40 by capital R. Now I'll substitute this IR here. Then what will I get? 40 by capital R is less than 5. That is, 40 by 5 is less than capital R. That implies 8 is less than capital R, which from this we can come to a conclusion that the value of resistance should be greater than 8 ohm. That is, R is greater than 8 ohm. So the value of this resistor should be greater than 8 ohm.
If you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. Do like and subscribe, because your single like and comment will encourage me for making better videos. Thank you.